Like to welcome Michael Avara from UIUC. He's going to be talking to us about Motus, and I'll let you do the introduction for the spiel and everything. But as a opening shout out, especially since he just joined, I'd like to give a big shout out to Bob Fisher. As everybody knows, we've been short of VP. So Bob stepped up and had some interest in this being a speaker topic and got me in touch with Michael and basically greased the wheels for the whole thing. So if you enjoy this, it's Bob's doing. If you don't enjoy it, it's my fault. So we'll go from there. But otherwise, warm welcome over Zoom to Michael Avara.
Yeah, thanks very much for inviting me and for tuning in on this stormy Thursday. I guess I'm just going to say in advance, I think this front is supposed to come through right in the middle of my presentation, so hopefully we don't lose each other here. But we'll just see. I'm about 2 hours south of you all. So, in any case, I'm here to talk to you about Motus and using radio telemetry to advance our knowledge of animal movements in the Midwest. I'm kind of the de facto Motus coordinator for the state of Illinois, just so you have a little bit of context. And that's kind of my large side mission. Aside from that, I do a lot of the lab management for Mike Ward's lab at the University of Illinois. So a lot of different projects we've done across the state, internationally, and even in the Chicago area. So without further ado, here we go into Motus. Let's see here. Okay, so as many of you, especially since so many of you are birders, you're very aware of the fact that birds are moving across the continent in large scales and large numbers, and you have different amounts of or degrees of variation of migration depending on the species and where you're at in the continent. On the one extreme, you have some of these shorebirds that will migrate from the very northern end of North America all the way down to the southern tip of South America, and of course, all kinds of migration trajectories in between to even just local short distance migrants, things that you might expect of like bluebirds or maybe thrashers or towhees. And science has shown us over time too that various geographic anomalies will sometimes guide or impact bird migration. You'll notice over here where we've got different trends on different taxa of birds. We're looking at seabirds, oftentimes, as you might expect, would be migrating way off the coast. And then you've got, of course, land birds, but also many waterfowl and birds of prey coming down through the central Mississippi flyway as it is that we're in. And especially those of you that are involved in some of the hawk watches, this particular green thread is of note that you have all these birds of prey, raptors that go along the coast of Lake Michigan near Chicago. The important thing, though, and the reason why we look at these migratory patterns is that while it's amazing that birds can migrate such great distances, and that's a great adaptation, it also is a very risky one, especially in a changing world. And many might be familiar with the Rosenberg et al. 2019 study that had shown the decrease in birds overall, large-scale decline, specifically in taxa like grassland birds, migratory grassland birds, aerial insectivores. And so it's really important from a conservation standpoint to understand what's driving these declines, and especially if this seems to be something that's indicative or unique among migratory birds. Of course, the difficulty of it is if you're trying to look at the decline of migratory birds, you can't just look at the decline in one area. Oftentimes with birds, you'll find that the birds are most noticeable when they're on their breeding grounds, where they've got their flashy colors and they're moving around a lot and they're singing a lot, almost incessantly. And so it's very easy, or maybe easier, to look at that stage of a bird's life cycle on the breeding grounds. But the reality is, if you've got a bird that's migrating, you also need to be considered about where they're actually overwintering and how things are in that particular case. So oftentimes with neotropical birds, we're thinking about areas in Mexico and Central America and South America. But even then, that isn't enough either, because obviously there's a large distance, or there's a large gap in time and distance between the breeding grounds and the wintering grounds. And things can happen on these areas in between. Oftentimes, birds have got to stop over somewhere along the way because they might not be able to make it all the way from their breeding ground to their wintering ground in one swoop, so to speak. Um, so it really brings up some complicated questions. And one of the big questions is where like if you have a declining bird, where is the problem occurring? Is it occurring at the breeding ground, at the overwintering ground, or spots in between? And we're looking at where these bottlenecks are in the migratory cycle. Is it because there's habitat loss on their breeding grounds? Is it because birds are colliding on their migration route? As many of you are aware, with the bird collision monitoring that goes on in the city of Chicago and the impacts that some of those barriers along the migration route have on birds. Pesticides and toxins like neonicotinoids on the breeding grounds can be a problem. Looking at for birds that are dependent on fish or birds that interact with the oceans, the impact that fisheries can have on bird populations. Of course, feral cats are another issue. Feral cats can really put a dent in bird populations, especially on the migratory pathways when birds oftentimes are stressed and exhausted from just making a very long flight to their next stopover site. Climate change, of course, can also cause a lot of issues, whether it's a mismatch in timing, phenology, green up, and insect emergence for neotropical migrants that are trying to time when they should come back to their breeding grounds from their wintering grounds. And also, and this kind of goes hand in hand, a lack of resources. If there's not enough food in the area, whether it's birds that are overwintering in a particular area, and there's not many resources or resources on the breeding grounds. So migratory birds can be quite vulnerable at multiple points in their life, multiple points in the year. And so it's tricky because you've got to study a migrating bird, an organism that's not staying still, except for maybe for a short period of time while they're breeding and maybe a little bit longer period of time when they're overwintering. And so some of the difficulties we face when we're trying to actually study the movement of birds include some of the bullet points that I have here. But overall, we're limited by technology and coordination. So one of the first bullets I have here is the limitation of technology. Oftentimes, you might be familiar with your GPS in your cars or your phones. We use GPS for a lot, and how neat would it be to use GPS devices to actually track birds? And it might not surprise you to know that we actually do. The tricky part is it tends to work better because of the battery size and the antennas and whatnot on larger birds. So you can see down there in the corner, I've got the Canada goose. It's got a collar around its neck, and that's a GPS transmitter. We actually put several of these out in the Chicago area when we were trying to mitigate goose patterns with some of the aspects and operations of O'Hare Airport and Midway, trying to make sure that geese were in the right spot, not in places that would cause problems for themselves and humans. And it might not surprise you either to know that those GPS transmitters with those solar panels you might be able to see shining on that transmitter there can have quite a long lifespan and can collect a lot of data. In fact, we've still got a couple geese from the study that I think we started about 8 or 10 years ago that are still have their transmitter and they are still broadcasting their location every few minutes. And the nice thing when you've got a bird like a hawk or a waterfowl or seabirds that have these transmitters is you can get a lot of data. And you can see over here on the right, this map with all the red dots, those are locations for mallards as they migrate north and south from their overwintering grounds and migratory stopover up to their breeding grounds. So really valuable data and really high resolution. You can see this kind of zoom in here on kind of the Delta region of Arkansas and Mississippi. You can see all these locations where the bird was hanging out. So it can really inform what we know about birds and as a result, then inform conservation measures. But unfortunately, as you can kind of tell with this meadowlark here in the center, there's a limit to how small you can go. And even this transmitter here, with its two antennas, looks pretty bulky on this meadowlark. Now, that particular transmitter was put on the bird, and it was in consideration of the bird size and stress level and whatnot. But that's about as small as you can go with a GPS transmitter at this point. So at that point, we've got to try to develop a different strategy if we want to figure out what's going on with smaller birds. And so one thing that was done by Mike Ward and company back in 2007, 2008 was they were working on migratory stopover and behavior of birds as they were preparing their next stage in migration when they reached the Gulf of Mexico and they flew down and the birds were refueling and trying to decide what to do. And they were really wondering, are the birds going to go all the way around the Gulf of Mexico? Are they going to go straight across the Gulf of Mexico? What makes the most sense? What birds are in healthy enough condition to do this? What's actually fueling these birds' decisions? And so what the researchers did was they banded and tagged the birds up here at Fort Morgan, Alabama, and then basically constructed this line of towers here in the northern part of the Yucatan Peninsula. And a bird that had a transmitter here would then fly across the Gulf of Mexico and be picked up by one or two, maybe even three of these towers. And it was a great opportunity for a lot of good data. But one of the things that you might appreciate just looking at this is how much time and money it takes to install all these towers, to fly down here, to get the equipment, et cetera, make sure everything's running. And it's a lot more than what most researchers can really do. And I'll talk more about what this kind of led to, though not directly, kind of indirectly. So this is a problem. Another tricky part is kind of the analytical approaches. So you want to track a bird's movement, and you put a transmitter on a bird to try to do that, but that could be kind of tricky in terms of what data are you going to get? How often is the transmitter going to pulse, and how are you going to be able to pick up that signal? And once you've got that, what will it tell you? Will it tell you something about how long the bird is there, how much the bird's moving around, when it departs, when it arrives? So that is yet another difficulty of this research. And then finally, also having the expertise to tag a bird. Just because you can catch a bird doesn't mean necessarily that you're able to put the transmitter on effectively. And sometimes they put like leg loop harnesses on birds. Sometimes they put backpack harnesses on birds. Sometimes they have like a 3D printed backpack. In some cases, for some birds, they actually implant a transmitter, although our lab doesn't do that. And just as a quick side note, so the Saw-whet Owl here that we put the transmitter on, that Chad has in his fingers here, anxiously waiting to put it on. We started with leg loop harnesses with these Saw-whet Owls, and we found out that they were very effective at taking the leg loop harness off. And so, then we had to go to backpack harnesses, and then we found out that they were very good at chewing through the material. So we had to get this spectra material that they only make at this special place, material engineering place in Pennsylvania, where if I had enough strands of this spectra fiber, essentially a helicopter could lift a car. It's amazing that an owl could chew through that. But those little owls, they give these transmitter harnesses a run for their money. And so all of these issues and considerations eventually came to a head, and people said, well, what could we do to try to overcome some of these obstacles? And that's essentially what Motus was the answer to. And Motus is kind of a collaboration, a network. It's not really an organization or a business or NGO or anything. It's just a collaboration of scientists, researchers, citizen scientists, NGOs, government organizations that are all in this to try to collaborate and answer some of these big questions about migratory birds. And I have the Birds Canada's logo up here because Motus is the brainchild of Birds Canada, and the servers maintained by Birds Canada and all that sort of thing. So what exactly is Motus? It's an automated radio telemetry network. So there's radio stations with antennas that are listening for birds with radio transmitters across the world. And it's a collaboration of many individuals and organizations. So you might remember those towers that we put at the Yucatan. Well, the nice thing about this is not one lab is required to put out a bunch of towers and stations because, everybody, I think you can see down here in the bottom left-hand corner, there's, as of last week, 2,371 stations. It'd be impossible for one person to do all that. But, harness the power of collective research, and suddenly that becomes a possibility. And then, of course, as I mentioned, Birds Canada is the central repository for data. Again, just to give you kind of an idea of the scope of Motus, people who have contributed towards Motus have tagged over 479 species of birds, or I should say animals, because sometimes this is used for bat research and butterflies. For those of you that might have seen the New York Times monarch butterfly article, dragonflies, a number of different things. And it's not just the United States, 34 countries, many of them in the Western Hemisphere, but although increasingly now in the Eastern Hemisphere, in the Old World. And then there's 1,043 projects, 261 publications, and counting. Okay, so what is a Motus station exactly? It's actually a pretty difficult question to answer because there's so many different people with so many different spins on this, and creativity and constraints, that from one Motus station to the next, things look quite different. But at the bare bones, what you're looking at is a Motus station has a receiver, a power system, cables and antennas, something to mount the antennas to. And then, in case you're wondering, it normally, because of the creativity, there's a range of costs. And so one of these stations might cost anywhere between $4,000 up to $10,000 or more. When it comes to the receivers, there's basically three companies that make receivers, CTT, Lowtech, and Sigma 8. And then we've actually at the University of Illinois have been making our own sensor domes with open source plans to actually make receivers, which is kind of nice to have that flexibility. Power systems, it's nice to be able to have a Motus system that you can plug into an electrical outlet. But the reality of that is oftentimes when you're trying to locate a tower, it's not really close to an electrical outlet. So oftentimes people are using solar power with charge controllers and big, heavy, deep cell marine batteries. When it comes to cables and antennas, there's a surprising diversity of especially antennas that are used for Motus stations. These are kind of the Yagis that you see people using, 5 or 6 or 9 element Yagis. And then when it comes to an antenna mount, sometimes people make their own tower like this. Sometimes people just tack it to the side of a building. So there's a surprising variety when it comes to what Motus stations will look like. And this just exemplifies this. So here we have, you might just barely be able to see, there's a faint outline of an antenna up here on top of a 90-foot tall water tower. Yes, it was a harrowing trip up this ladder, but we made it. Down in Mexico, they oftentimes will use what they call tubos, so conduit. And this is about 15 to 20 foot tall tower, so to speak. And then you see the antennas attached to that on top of the roof. This is kind of nice in that this is in the Yucatan where they've got, hurricanes and all kinds of interesting things that happen. And you're not out much if the conduit snaps. You just buy another piece of conduit, tack it back up, and you're good to go. This is... I put this picture in because these are our custom antennas that we made at the University of Illinois that are high gain antennas that you oftentimes will see at some of our stations up in the Chicago area. And then here we've got kind of one of these round towers in the middle of southern Illinois, the nice clear horizons. And so Motus stations look very different depending on where you're at and what your budget is and what your constraints are, research questions, all that sort of thing. So when people are going to put a tower up, because it's very tempting to just put up a tower wherever you deem fit, but all towers are not created equal in terms of how effective they are at picking up birds that are migrating through or birds that are bopping around in the area of the tower. One thing that's a consideration is background noise. So here I've got what I call the tale of two towers. At the top here, this is a tower with little noise, and this is a tower with lots of noise. And we'll tease this apart a little bit. So notice both of these towers have one, two, three, four antennas, and you'll see these little colored blips on here are signals. They could be noise signals, they could be an actual bird. And you'll notice there's actual gaps here where, there aren't signals. So that means there's no noise and no bird at all. And then you see this is just being bombarded constantly with noise, right? This incidentally was in near Homer Glen. And there was a high voltage line nearby, and then, of course, a whole bunch of other radio noise from other sources. Here you'll notice this tower with very little noise actually has some detections on here. That's what these circles are down here. Here we've got, this is a saw-whet owl here, and here we've got a nightjar, that's what I believe is a nighthawk. So a lot of different things popping up because this station isn't constantly bombarded with noise. So when it comes to tower or station, Motus station considerations, you also need to consider power sources, like I just mentioned earlier. It's really nice to not have to worry about if your batteries are going to go dead or if there's not enough, especially this time of year, if there's not enough sunlight to power the solar panels. But then again, we've also found in Mexico where the power grid isn't always as reliable as you'd like, that plugging it into an electrical outlet isn't always a guarantee, surefire way to make sure that the tower or station works all the time. Accessibility is an issue. I jokingly say you definitely wouldn't want to put something up here that you'd have to access all the time because it's quite a harrowing climb. But at the same time, too, you don't want your Motus station to be so accessible that anybody and their brother can come and mess with your equipment and vandalize or steal. And so striking that balance is really important. And then also having clear horizons and expanding your detection radius as much as possible. The reality is in Illinois, especially, a lot of the public lands and conservation easements that we have are in low-lying areas around waterways. So even though a lot of times it makes the most sense from a wildlife standpoint to have Motus stations in those river valleys, at the same time, it also reduces how far away you can actually pick up a bird. So I've got a bird with a transmitter and it's broadcasting that signal, but it can't reach the tower because the tower is on the other side of this hill. So what does the Motus station detect? Ideally, it detects the radio transmitters that are emitting frequencies. For Motus, there's three frequencies that the transmitters broadcast at. It's 166.380, which is the majority of tags that we put out in Illinois and the Midwest. But then there's another frequency at 434 megahertz, and then a third one at 2.4 gigahertz. One thing I want to point out is that these transmitters are only detectable if the station has antennas at the same frequency. So for each of these antennas, you have to have, or each of these frequencies rather, you have to have a different antenna to detect the birds, which can get kind of expensive if you're looking at trying to mount three different types of antennas. And that's why for the short term in Illinois, most of the stations that we actually have installed and are function or are maintaining have just the 166.380 megahertz. Is it possible to add these other frequencies? Yes, it's just like anything in life, time and money. When it comes to these frequencies, a logical question that a lot of people oftentimes ask is, well, if all of your birds are at this frequency, how can you actually tell, which bird is there and when that bird is left or where it's moving? And essentially, what they've done with Motus is they have a coordinated set of codes. Morse code would be the best way to kind of explain it, where each transmitter basically generates its own pattern of code. So usually each transmitter puts out a really quick burst of 4 radio pulses, and they're only separated by like just a few milliseconds. But it could be that instead of one transmitter that's coded one way, just doing like a dot, 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 instead it might be doing a dot, 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 dot. And now that's a different code that's picked up by the receiver, and it says, this is the American robin that was deployed in Champaign, Illinois, instead of the hooded merganser that was deployed in St. Louis. So what types of data can these Motus tags and that are detected by the receivers, what can it provide? One of the biggest things that Motus transmitters are used for is to try to get a better idea of when migrating birds depart, especially from stopover sites. And so that gives us an idea of how long the bird is staying at that stopover site, which might be indicative of how good the habitat quality is, how good the food is, so that they can refuel before they have to go on their next leg of their journey. Oftentimes, it can also tell us a lot about the migration routes that birds take, especially if it's detected at one Motus station and then 5, 10 hours later it's detected at another one, several hundred miles away. It can tell us a lot about local movements, especially if we put like a Motus station on the breeding grounds and the birds moving around the landscape where we have Motus stations. It can also tell us a lot about behaviors. This is a lot of what I do with the Saw-whet Owls, for those of you who might have heard me speak before, where we put a transmitter on a Saw-whet Owl and it's moving around on its wintering ground. And we can tell that every time that there's a change in how loud or strong the signal is and the direction that's being picked up on, we know that that change in the signal correlates to a change in the bird's activity. So we can tell if the bird's more or less active at some points or another. You can also kind of tell the concept of territoriality. If we know like where the bird is being picked up around the tower and if it's isolated in that same general area, especially if we have 2 or 3 stations in relative close proximity so we can triangulate the bird's location, we can actually come up with what we call home ranges or each bird's territory. Let's see here. There we go. So what species can be tagged and by whom? It is a requirement of the bird banding lab in Washington, D.C. to have permissions to actually capture, handle, band, and tag birds. And they do require that you have a research question and that you have some amount of training to make sure the bird's welfare is being taken into consideration. And also we look at they look at if you've got an appropriate species. So I mentioned earlier that you don't want to stress a bird out too much by putting a transmitter on. So the appropriate transmitter should be less than 5% of the bird's mass. And oftentimes I'll get questions about, well, what kind of transmitters do you put on, or how big are the transmitters and how long do they last? And so this is just a table I included in here just to kind of give an idea. Some of the bigger Motus transmitters, if you can get a bird big enough that 12.4 grams is 5% or less of the bird's mass, you can get a transmitter that, if you allow it to pulse only every 29 seconds, will last 4,202 days, which is a pretty long time, and it can actually give you quite a bit of information. On the flip side, many of your smaller birds, especially like warblers, are going to need a really, really small tag. So you might be going more with like this 0.13 gram transmitter. And if you want really high resolution data, you might want it to pulse every 3 seconds. Well, at that rate, that transmitter is only going to last about 12 days. So you got to think about, okay, is that going to address the research question that you hope to get at? So it's kind of this trade-off between tag size and how fast it pulses and what your research question is. And then, of course, there's all kinds of options in between there. So a Motus is something for those of you who have never, and this is one of those things I might have asked you at the beginning if I could have seen everybody's hands, but oftentimes Motus for many people is a new thing. They might have heard of it, but they might not have known what it was. And that's fair because it is a relatively new thing. It was started, as I said, kind of back in about 10 years ago now, in kind of the Northeast and Canada. And it's grown quite a bit over time. You see it kind of in Canada, in the Northeast, along the Eastern Seaboard. And then as we get into our first kind of real, we got serious about Motus in Illinois was about 2020. A great year to start things, right? And you'll see things start to get crowded around Illinois and the Midwest. And then things just ballooned after that and just
Hey,
went crazy.
Brian. Could you tell me the verification code you just got?
And so when we talk about Motus, now we have quite a station or quite a number of stations across the United States. And especially now there's been increasing interest and investment in Latin America. Because as you notice, most of the stations, and this might not surprise you, are in the United States. But these areas along in here and points further south are as important, if not more important, when it comes to trying to look at the entire life history of a bird on its breeding grounds, stopover sites, and then on its wintering grounds. And we've been involved quite a bit. I'll talk a little bit about Mexico and our lab's involvement there. So where is Motus in Illinois? This is kind of our snapshot of where our stations are. As we were looking at trying to site these stations, we knew we only had so many funds and we only had so many people to be able to maintain these stations. So we tried to prioritize the placement of stations in areas where we knew we would be deploying tags for research questions and where we knew there were high concentrations of birds moving through, so we could increase the likelihood that we would have birds actually passing by the stations and being detected. And so it wouldn't surprise you that this area along here, that many of you are familiar with and live in, along the west shore of Lake Michigan, is a really important spot to actually have Motus stations. However, we have to balance that with the fact that we've got a lot of radio noise that you would expect also with a city environment or urban environment. So we've tried to place, because Illinois is such an important migratory corridor, especially when you talk about the Mississippi River and the Wabash here on the other side, we've tried to place the stations along kind of transects. We place them every 15 to 20 miles to try to make sure that we increase the likelihood that if a bird crosses Illinois, it'll be picked up by one, two, or all three of these lines. This provides detections for birds migrating through Illinois, especially boreal migrants. And we found that when birds fly through, it's actually possible with this spacing to actually pick up a bird at two adjacent stations at the same time, which is kind of cool and kind of validating. We have arrays of Motus stations at certain spots in the state, like at Kennecook County Park. We have 6 stations there because we've done a lot more intense tagging efforts there. And also we've been looking at trying to triangulate birds' movements and that sort of thing. Also at Allerton, one of our other big deployment sites, and at Emiquon up here by Havana, just downriver from Peoria. And I will say of all these stations, the leading station for the most detections of tags that weren't deployed right there at that site is actually right down here, just south of St. Louis, right along that Mississippi River corridor, which might not surprise you. So it's kind of interesting to see some of the patterns that Motus has already been showing us. Okay, so I did want to do kind of a snapshot of Motus projects in Illinois, so you kind of had an idea of what research was going on with Motus and what we've been trying to answer in terms of research questions and some of our initial results. So this first project is a retired project at this point. It was one done on Sora and Virginia rails by Chad Kramer, who was a graduate student at that point in time, and Ariel Fournier, who's at the Forbes Biological Station over by Emiquon. And they put tags at Emiquon National Wildlife Refuge and Banner Marsh State Fish and Wildlife Area. And we had 4 stations at Emiquon and 2 at Banner. They deployed a total of 188 tags over the course between spring 2021 and spring 2023. Put tags on 68 soars and 120 Virginia rails. And they were looking at trying to characterize fall and spring stopover duration and departure behavior, and then also to better determine the route of rails as they were flying, as they were migrating in the spring and in the fall. Oh, and there's our rail walking around there. Cute birds, but boy, are they hard to see. And so as we're looking at the Virginia rails in particular, you see this lime green was kind of where the birds were going in the spring, and in the and then the orange we've got in the fall. And this is an incomplete picture, and it looks a little bit of a mess because one issue with Motus is you've got to be able to try to detect what's noise or differentiate between what's noise and what's a true signal. And so there's a lot of post-processing that has to go on. What I will tell you that actually isn't shown on here quite yet, because we just updated this map a few days ago as we've started to go through all these detections. And there's only like, 30 million when you're first beginning processing. So it takes some time. But we've started to notice that some of these rails are doing kind of what we're considering a elliptical migration pattern, where they're going up a little bit further off to the west in the spring and coming back down a little bit further east in the fall. And we're not quite sure what's causing that elliptical pattern, what's driving it. It could be it could be the predominant weather patterns at that point in time. It could be that there's some resource stopover sites that they're queuing in on. And so we're looking more into that as we better fine tune the paths that the data we've collected are showing. I'm going to talk very briefly about the Northern Saw-whet Owl project that Mike Ward and I have been doing, where we've deployed tags at Kennecott County Park near Danville, Illinois, where we've got an array of 6 towers there. We have partner deployment sites at Sam Bluff near Rockton, Illinois, at Allerton Park near Monticello, Illinois, Cedar Grove near Milwaukee, and Jubilee Farm near Springfield. And cumulatively, we've put 125 tags on Northern Saw-whet Owls from 2022 to the present. And the purpose was to characterize fall and spring migratory behavior. So how long are they staying over as they migrate through? And when are they departing? We're looking at characterizing winter behavior. So looking at activity and vocalizations. Specifically, if we play a call and we're standing next to a tower, is the bird moving towards us, which is the call is attracting the bird, or is the bird moving away? Behavior that would be more associated with avoidance. Then we're looking at characterizing habitat space use during the fall and migratory stopover periods. And then most recently, we've shifted a little bit because one of the big questions that a lot of people are really wondering about saw-whet owls is what's going on with this sex-differentiated migration strategy. So for those not familiar, of the birds that we catch in Illinois, 80 to 90% of them are female. And so we're kind of wondering where the males are. Are they not migrating? If not, where are they going? Where are they staying? And why are they staying? And so we've been working in northern Wisconsin this past year, tagging birds there to try to understand more about that. And so here's some tracks we've got here of saw-whet owls. And this was just from one season, actually. You'll notice a variety of different strategies they're using. We had one bird that actually went up through the Chicago area and along the western lakeshore of Lake Michigan. But at the same time, we had a bird on the other extreme that went all the way over here through Detroit, or past Detroit, I should say, and through this area of Ontario between Detroit and Toronto. And then still others, go straight up the state of Michigan and right through the Straits of Mackinac and up to Whitefish Point. So really some fascinating things that we've been able to determine over the course of this period in time. I labeled this as a project in Illinois. This honestly is more of a project in Wisconsin. It started as a project in Illinois until we realized how difficult it was to actually capture black-billed cuckoos in Illinois. Much easier in Wisconsin. And so we took a leap of faith and we went up to central and northern Wisconsin and tagged some cuckoos, hoping that they would pass through Illinois at some point and be detected at some of our stations along those fences. And as it turns out, cuckoo movement is sporadic and as unpredictable as we could as we could possibly get, I think. But what is interesting is these cuckoos that ended up all the way down in Costa Rica, Panama, and point south into Colombia. And we're excited to see, since a lot of these were actually tagged this year, we're excited to see where these birds end up in the spring. And so one of the objectives by this study with TJ Benson and his grad student Katrina Tyson was to better determine the route and timing for spring and fall migration of cuckoos. Their early thoughts on this, that it might have to do something with the outbreaks of insects that cuckoos can monopolize on. So things like cicadas, especially the periodical cicadas. But as you know, periodical cicadas don't exist across the entire eastern U.S. every year. It's kind of a spotty thing. So we've noticed that tent caterpillars would be another one, gypsy moths. So these things, these species that cuckoos are zeroing in on. We're also doing a project on short distant migrants. This is led by Nat Deschwal over at Bradley University in Peoria. He's deployed 20 tags in southern Missouri, central Illinois, and then northern Wisconsin, both this past year. And then he has plans to detect or to deploy more this year. He's looking at better determining the route for spring and fall migration of things like brown thrashers and eastern towhees, these kind of shorter distance migrants, and then better understanding their site and route fidelity and the impacts that climate change might have on these regional migrants. Much different from some of the neotropical migrants who are migrating all the way down to Central and South America. These brown thrashers, we picked them up on our Christmas bird counts down in southern Illinois just a few weeks ago in southern Missouri. So really an interesting project. One of the poster child projects for Motus the past 2 years has actually been the wood thrush connectivity project. And while I have Mike Ward listed there at the University of Illinois with his grad student, Lauren Brunk, I also included Roberto Souza, who is in Oaxaca, who was really instrumental in helping us tag wood thrushes in Mexico. And this is just a very small portion of the literally 100+ people that were involved in this massive project. While we deployed 71 tags in Illinois, primarily Lauren Brunk and I, over the course of 2024 and 2025, this was part of a much larger international effort to deploy over 1,000 tags, and they accomplished that goal in 27 states in Ontario, Mexico, Guatemala, Honduras, Belize, Costa Rica. It was just massive. It was a collaboration of government organizations, U.S. Fish and Wildlife, state agencies, DNRs, that kind of thing, but also a lot of nonprofit organizations. And in Illinois, we had 3 kind of main deployment areas. We had northern Illinois, so we had a station at Chain of Lakes Park and at Sand Bluff Bird Observatory. We focused our efforts there. And then we put some out in central Illinois at Kennecook and Allerton, our main sites we deploy tags. And then southern Illinois, actually down by St. Louis, that station I was mentioning to you earlier, at Illinois Ozarks Nature Preserve, White Rock Nature Preserve, Salt Lick Land and Water Reserve, and then Camp Depoy. And then, of course, in Oaxaca, we went in February while birds were on their wintering grounds to tag them there at San Luis Potosi, or not San Luis Potosi, San Mateo Yetla. I need to fix that. The whole purpose of this massive undertaking is to better understand the nature of the decline of wood thrushes, and then these tags will be deployed on wintering grounds during migration, on the breeding grounds. So now we're getting at that full annual life cycle. And it's really important because the wood thrushes have been declining across their range, but not to the same degree in all spots. So there's something going on at some point in that full annual cycle, and being able to do a project on this scale actually helps us tease that apart a lot more. We have tons and tons of data. These birds, the tags that are on them right now, there's birds in Oaxaca right now and that we anticipate will migrate back north. This will give you an idea. This is just the birds that were tagged in Illinois. It looks like a messy pile of blue spaghetti here, but the overall trend I want you to notice is that obviously these birds are flying south into the Yucatan and down into Guatemala and Belize, maybe even into Honduras to overwinter, and then they come back up, sometimes straight across the Gulf, sometimes around. You'll notice there's a few tracks right here off to the western Gulf along Texas. You'll notice this picture right here on the map is their beautiful wintering ground in Oaxaca. Here we have Lauren and her colleagues actually tagging wood thrushes that they just captured in a banana plantation, a little bit different from Illinois. And then here you'll notice a wood thrush flying off with the antenna for the transmitter right behind it. Okay, another project. We've got a lot of projects in Illinois. been managing Illinois' fragmented forests for migratory birds. So this is a project that's spearheaded by Benjamin Van Doren and his grad student Annika Abbott. So they've deployed just this last year over 100 tags during spring and fall migration at migratory stopover sites in central Illinois. Because we know that Illinois is a fragmented landscape, forests oftentimes are present, but in patches. And these migratory birds that are forest birds are having to try to find these patches and hopefully find enough fuel to continue on to the next leg of their journey. And so we assume that these patches are not created equal. We're trying to get an idea of what does a good forest patch look like, or a good rest area, if you will. How long are the birds staying there compared to other sites that might be less appealing or less productive? And so in central Illinois, we've been working at Kennecook, in Vermilion County, Allerton and Piatt County, and Phillips Tract in Champaign County, where we actually have a migratory bird banding station. And we're looking at determining if site attributes alter migratory bird stopover behavior in ways such as the length of stopover, how far and fast the birds travel after they depart, as well as how migratory behavior may differ seasonally and across age groups. In case you're wondering, because I just keep using the word bird on this slide, and you're like, well, what species is it? This project is interesting. That's a whole bunch of species. And as a result, we've had to use a variety of different size tags, a lot of thrushes and warblers, and especially northern water thrushes and ovenbirds. And here you'll notice here we've got a warbler, and it's got this little transmitter on it. And so here's some of the preliminary data. This is from the spring. Here's our 3 tagging sites. And this was the whole purpose, was to have this line of stations across northern Illinois, the Wisconsin border, so that when these birds would cross, they'd get detected, and indeed they were. And even they were detected as they went further north and west into Wisconsin and Minnesota, and some of them all the way over to British Columbia. And I should also say these are mainly thrushes, so Swainson's thrushes and veeries. There are other, there's a bunch of Motus projects going on across the world. I'm not going to attempt to go through all of them, but I will mention a couple where we have picked up birds migrating through Illinois that were not actually tagged by us. So there was a project done on dark-eyed juncos by Alex John and Sam Dietrich in Indiana, and they were looking at the responses of juncos to artificial light at night. Obviously, birds migrate at night, and so if there's more artificial light at night, one would think that that would have some impact on when the birds might depart or what direction they might go, et cetera, et cetera. So they deployed 39 tags in 2022 from near Bloomington, Indiana, and we detected, I think, about 4 of these actually crossing the Illinois-Wisconsin border at Illinois Beach State Park, Chain of Lakes State Park, and then we have another station at Woolworth just north of McHenry County, the first week of April 2023. And here they are, all these different juncos as they're flying up towards the Chicago area and then diverging as they go to their different breeding habitats. There's a major project on Swainson's thrushes in British Columbia by Hannah Justin, Kira Delmore, and Wendy Easton, where they put out over 600 tags from 2019 to the present in British Columbia. And they were trying to look at if birds tagged on one side of the mountains up there are actually interacting and behaving the same way in terms of migration. If this is some kind of subspecies hybrid zone, how much they're interacting. And what that has led to in the United States is a whole bunch of Swainson's thrush detections. One of the most interesting ones, go back here. One of the most interesting ones flew all the way across, was detected near Winnipeg, took a hard right when it got to Lake Superior, and then hit a few stations detected as it was going down the shore of Lake Michigan. And I thought the path had pretty well ended right here at Goose Lake in Indiana until Mike Ward and I were down in Costa Rica, and we had to give a presentation. And Mike said, just throw a presentation together really quick and show the people, 1 or 2 of the tracks of a bird that was detected there. I thought, well, okay. I thought the Swainson's thrushes, they're some of the furthest flyers that people tag. And I thought I'll look up a Swainson's thrush. And just so happened the Swainson's thrush I looked up was this one. And the path actually continued. And come to find out, the place that we were at in Costa Rica was only about maybe 50 miles from where this same Swainson's thrush was detected only 2 weeks before, which was an amazing thing to communicate to the people in Costa Rica. And it really makes you appreciate the fact that, it takes collaboration between people across the hemisphere, in the United States, Costa Rica, and other countries to really understand and appreciate what these birds are going through and what it takes to actually conserve them. Okay, so how does this inform our understanding of migration? So, as I mentioned, in a changing world with changing climate and all of the urbanization and impacts of human settlement of the land, habitat change, all of that, it's really important for us to understand where birds are migrating across the landscape so that we know what obstacles lie in their path, so that we know what opportunities they have to refuel, so that we know what the likelihood is that they'll be able to return to a location to breed or return to rest for the winter. And that's mainly what we've seen with the rails and the wood thrush work in Oaxaca and Illinois, this whole concept of where the birds are going. This particular map exemplifies this. Down here where this white symbol is down in Mexico, this is where we deployed the transmitters on the wood thrushes in Oaxaca. Imagine my surprise when I went to check our Motus stations in Illinois about 4 months later, when I realized that one of these wood thrushes from Oaxaca actually was detected about 20 miles from our family farm in southern Illinois, and then ended up in Allerton Park, and probably to points further north where it wasn't detected. I'd like to joke that the bird, was missing me, or maybe it had a vendetta, it wanted to get revenge on me, so it followed me back to Illinois. But the reality is we had no idea where these birds in Oaxaca that were wintering there actually went to breed. And we're still not 100% sure, but at this point, with the Motus stations that we have, we've been able to narrow it down that we've got birds that we tagged down in Oaxaca that were breeding in Wisconsin, Michigan, and or Illinois. All right, and then of course, how this informs conservation, we know, or we hope to know from Annika Abbott's research, once we're able to determine, what type of habitat is being used for stopover migration for birds and what size and what type of food availability, that sort of thing. Once we characterize that, then we know what type of high quality stopover sites to actually conserve, what land to set aside, and how best to manage that to increase the likelihood that migratory birds have a fighting chance to continue. I also want to do just a quick shout out that it's so important that we have our connections with Latin America with this research. And there's many I could mention here, but one I wanted to highlight is the one with Paco Vega, who's actually a graduate student with Roberto Sosa, who I mentioned earlier in the program. And he's actually looking at the migration of birds in and through Mexico to the United States. So he's looking at actually tagging more of these birds in Mexico than what we typically do, because usually we've got the complete opposite approach where we tag all these birds in the United States and just hope that they're detected in Central Illinois or Central America and Mexico. And Paco is becoming a Motus guru down there and really helping expand the network, which is really what we need to inform a lot of these projects. Expansion in Latin America. All right, so I've mentioned a whole bunch of projects. I mentioned the overall concept of Motus. So what's next? Right now, it's a picture of myself and Mike Ward, by the way, on the right there. We're looking at upgrading equipment and station optimization. We've had some of these stations in operation for the past 5 years. And just like anytime you start a new project, you look back and you say, boy, I wish I'd realized this at the very beginning. And so we're making those adjustments, course corrections right now to increase the efficiency of the stations and the network that we have in Illinois. Replacing old equipment, damaged equipment, because that happens over time, whether it's insects or rodents or lightning or all kinds of stuff like that. And then deploying additional tags, because tags are a finite resource. Tags are one of those things that only last so long because the battery eventually goes bad. And so as soon as the battery goes bad or the bird dies, then we don't have any opportunity for future data. So it is a constant cycle of deploying tags to address these research questions. In case you're wondering what you can do to help, one thing I will mention is across the state, as you noticed that map I showed earlier of Illinois, we at the University of Illinois do maintain most of those stations, probably about 35 of the 40 in Illinois. And there are only so many of us to go around, and some of them are quite far from campus. Thankfully, we do have some very dedicated individuals in Northern Illinois who check our line of stations between Chicago and Dubuque. But in Central and Southern Illinois, we really struggle to get to them frequently, at least more frequently than the every 6 months that I'm able to physically do myself. So if you're ever wanting to go, birding in Central Illinois or Southern Illinois, and you're looking for something extra to do or want to see what a Motus station looks like, boy, have I got the job for you. So anyway, that's my shameless plug. But also in terms of what you can do to help supporting projects to put out tags. Tags are an ongoing expense, and tags cost about $300 a tag. And they could last anywhere between, like I was showing you that table earlier, a few days to 4,000 days. So these are important in terms of trying to make use of the network that we have and answer the research questions that we still have. What does the future hold? More tags, as you could probably guess, to actually further the research that we're conducting. We're looking at better analytical approaches. Dr. Van Doren at the University of Illinois has been using acoustic sampling near Motus stations. He's actually got an acoustic recorder at each of the stations along the northern line between Wisconsin and Illinois. And it might be that we can leverage that data with the Motus data that we've got for birds that are tagged and flying by to get a better understanding of what's going on. And then we're looking at developing educational materials. The one that I'm showing here, it's the major initiative that we've started this year. So we're calling it the Illinois Bird Explorer. For those of you who have been around in Illinois for a while, there's actually quite a bit of bird data in the state, whether it's spring bird count data, BBS routes, the hawk watch, the hawk monitoring, moon. I could go on and on. We're actually looking at putting this all in one website, making it friendly for the average citizen scientist, but also giving your average person access to the data to actually see what's going on, and putting this together, analyzing it in a way where people can actually see what these monitoring programs are generating in terms of data and what trends and patterns you'll notice. So it's a heavy lift, and we're going to need support as we go forward, but I think it'll be pretty cool when we're finished with it. So with that, that's kind of the end of my talk, as it will formally. I do have, because I know sometimes it's hard to actually ask questions on a Zoom format, but if you do have questions that aren't answered here, lingering in your mind, please feel free to reach out to me via email. My email address is there, avara@illinois.edu. And then also, I'll also put out that our lab website, which I'll go to hopefully here really quick, does have a research tab, and it has information about the Illinois Motus Network. And please feel free. We've got newsletters we send out every migration season, and we've got all kinds of information there. So feel free to look at that. So yeah, at this point, I'll open up the floor for questions.
Hey, Mike.
Mike, it's Bob.
Oh, go ahead,
I have
Bob.
a very basic question.
Mhm.
What does a tag cost?
So a tag will cost about $300 per tag.
Hey, Michael. Great information, very interesting. And I was looking forward to this because I saw some promotion for a device that someone put in the chat called Terra Listens. I think it was a Kickstarter. You're probably familiar with that.
Yep.
They do have a variety of antennas. It comes with an internal antenna, which has a pretty short range, kind of yard level, and you can upgrade to like larger antennas that aren't huge, but have fairly local, if you will, um, range. And they only provide, I think, the 5 gigahertz and the 433 megahertz. And so I'm wondering, as someone put in the chat, like, do these meaningfully detect species around here? Because I think you said something like the 166 megahertz was mostly used for projects around here.
Right. Yeah, and the main reason the 166 megahertz transmitters are used primarily by the research we're doing in Illinois is because those are actually, as of like a year or two ago, the smallest transmitters we could get to actually put on some of those songbirds. I'm familiar with Terra, but not enough to know how far it could pick it up or if it would be able to encode because it's not enough to just actually pick up the signal. It's actually got to be able to decode which signal it is. But I'm going to have to look more into that to see if that, because that's never been anything that was brought up in any of the Motus meetings that I brought up, but it has me wondering why not. So I'll have to look into that.
Yeah, so now I got a follow-up question. So I was interested in this. It's a device that does like it uses BirdNet to do like a local kind of like yard level audio detection of species, but it does say that it will tell you what species are being picked up by
Mhm.
the Motus I guess receiver, the antennas. Um, I don't think you really have like access to the data as someone who uses the device. I think the company kind of keeps it. And so that brings me to the second thing, which is I would imagine it's a young company. They say they want to contribute to science. Is
Mhm.
would a device on such a small scale like that, the small range, be helpful? And that's maybe a different thing that if they get enough of these out there, it provides some granularity. But then I did a little Googling, and there's like websites on kind of almost like a DIY set up your own Motus station. And so I guess I saw that there are some like official sponsor a Motus location and other things. And
Mhm.
I guess that the string of questions I have are, is it possible to set up if someone were interested and had some finances, a small scale or what scale would be useful Motus monitoring station, and
Mhm.
then kind of like yeah, like at what level would that even be helpful or possible?
Yeah, and it's interesting you bring that up because we've kind of gone through these phases as Motus has expanded across and become more and more present in the citizen science arena and also even in the research arena at the same time. And there was this massive push probably about 4 years ago to have more stations. And um, what we found is a lot of people that were putting out stations meant well and they had good equipment, but a lot of times the location for where they were at wasn't always ideal, and then they ended up kind of disappointed when they didn't get as many stations. So if you think back to those considerations I mentioned earlier about like radio noise in your environment and how good of a horizon you have and what type of antennas you can use, that kind of thing. Um, and once we got kind of the basic framework in place in Illinois, thanks to contributions by actually some very prominent figures within your birding club, and then also other organizations, nonprofits, etc. Um, we found that the most important expense and because you could put $4,000 towards a pretty good station, or you could put that towards several tags, right? And there was a mismatch for a while where we had a bunch of towers and stations, but nobody was putting tags out, so nobody knew if their stations were working, and it was really kind of a disappointment. So I think right now, when it comes to Motus research, the biggest help for people that want to get involved and really want to advance the research is being supportive of tags and tag deployments, because it's an ongoing expense that if there weren't tags, the system wouldn't have any detections. So
Where would we direct donations to your project?
So for those who might be interested, we do have on the lab website a tab for donations, and it's through the University of Illinois Foundation. Let me see if I can pull it up really quick. Yep, there's a donate tab, and this is a donation that you can actually write off on your taxes, and it tells you the instructions right there. So for those interested.
Thank you.
Thank you. Other questions?
You might not have seen it, Mike, but there's a question in the chat about whether or not the monarch tags are picked up by Motus.
Oh, yeah. So that's a good question. In Illinois, we don't have the 2.4 gigahertz antennas yet. That's a relatively new thing that CTT has just come out with. It's kind of it's a very interesting technology they're using because it's such a higher frequency radio wise than the other two frequencies, requires totally different antennas, and it's a much shorter wavelength and a higher frequency, and as a result, the radio wave doesn't pass as far. So that means the organism actually has to be a lot closer to the tower than some of the other two frequency antennas or transmitters rather. But there's an interesting caveat. They're using also a technology that's used in Europe. It's called a low T network, and I don't understand all the nuances of it, but basically it kind of goes back to what we were talking about with the Terra apparatus, where there's devices that can actually listen at this particular wavelength that are just part of just other types of devices that you have in urban areas. We don't have the same, like Europe has a really strong network of these devices, such that's why Europe really hasn't jumped into Motus, because they already had this network that if they just made these tags that took advantage of the low T network, it would pick up the organisms. So these monarch tags, it's really kind of interesting what they're doing, and it's still in the early stages in terms of technology and development. And yeah, it's interesting to see where it might go. Someone had in here, if we make a donation, can we somehow keep track of our tagged bird? The answer is yes and no. It's a little bit complicated. I don't know if I can actually show, because if you go to the Motus website, let me go back. So the Motus website is open source for anybody who wants to access it. The trickiest part is actually being able to figure out where the information is on it. But the link that I just clicked on our Motus website for Illinois, it has a link for each tower. And so if you wanted to know like what birds have visited a tower, like this is that one that I mentioned just south of St. Louis. Every one of these tracks is an animal that was detected. Or if you prefer, you can actually look at a table that has all the birds that are detected there. Alternately,
Michael,
yep.
it's showing your PowerPoint still, not
Oh,
the
sorry about that.
web browser.
I'm glad you said something.
Sorry, took me a sec to find all the mute buttons.
Yeah, and I don't know. You can't see it right now, huh?
No, we just got whatever screen's got your PowerPoint.
Okay, well, maybe I can't show you. But I will say on the Motus website, what it shows is basically for each project, it lists all of the tags on there, and you can click those at any point to actually see. And it is something that updates as data comes in to each station, so it's not a static thing. So in that way, you can actually keep track of it. It's just sometimes it's a little tricky to actually access. But it is one of those things, if someone were to if they wanted to keep track of a tag, there are ways we could provide instructions to follow that.
All right. Anybody else with questions?
I'll ask one last question. This is Bob again. As a hawk watcher, how come there aren't more tagged hawks, or maybe there are?
So there are people that are tagging hawks are usually using the satellite transmitters because most hawks are large enough to be able to carry one, where it's giving a GPS location and then it's automatically sending that to like a cellular network or to a satellite. And in fact, that's the same type of technology we were using with the black crowned night herons in Lincoln Park Zoo, because the black crowned night heron was big enough that um, we could actually put it on that bird. For something like you know a Connecticut warbler, that's just way too big. I will say too, they've had a lot of success, especially with red-tailed hawks and red-shouldered hawks, in tracking them because they put those solar panels on them, and those birds get up there way high in the atmosphere where there's not as many clouds, and they recharge and they'll last for years. So the quick answer is they're just not using Motus as much because um, they know they can have the more locations and the more up to date, frequent locations with the GPS transmitters that are bigger.
Anybody else? Cool. Well, thank you very much, Mike.
Thank
Uh,
you.
this was fantastic. I hope everybody enjoyed it as much as I did. Um, so yeah, we'll call that a wrap for the evening. Thanks again, and everybody enjoy the rest of your rainy evening.
That's good. We'll see you all.
Bye.